Here's number 8 from page 362. At one time, Maple Leaf Village had North America's largest Ferris wheel. The Ferris wheel had a diameter of 56 meters. One revolution took 2.5 minutes to complete. Riders could see Niagara Falls if they were higher than 50 meters above the ground. We want to sketch 3 cycles of a graph that represent the height of a rider above the ground as a function of time. If the rider gets on, that's if the rider gets on at a height of 0.5 meters at 0 minutes. Then determine the time intervals when the rider could see Niagara Falls. So determine when they're above 50 meters. Okay, I see a little problem with this. It says they get on at 0.5 meters, like when the time is 0, but it doesn't say if they get on at the bottom. I'm just going to go ahead and assume that it means that they get on right at the bottom here. All right, so let's fill this graph in a little bit. Now, we really care about the, like one full revolution is at 150 seconds here, but we always like to do the halfway and a quarter of the way. These are kind of like our main points, 1 quarter, 1/2, 1/3, because on a circle that kind of represents top, bottom, and sort of left and right. So the rider gets on the bottom. After one full turn, he's going to be back at the bottom at 0.5 meters. After another full turn, so 5 minutes, he's going to be at the bottom. After another full turn, he's going to be back at the bottom after 450 seconds. Halfway, he's going to be at the top. Halfway between each set, he's going to be at the top. And at the top. A quarter of the way, it's going to be in the middle somewhere. So the middle would be 28.5 meters. All right, so we got right here, there, there, and there. Okay, we're going to draw this, make sure it's curvy like a sinusoidal. I'm not doing a very good job of this, but really doing my, well, I can't say it's my best. I'm trying. There we go. So there's 3 full cycles. All right, so they can see Niagara Falls here, here, and here. It's up to us now just to find what time they get to that 50 meter mark. All right, so let's try it out. So we know that, let's say the height is going to be equal. I know it's a sinusoidal. I know that it has a radius. This Ferris wheel has a radius of 28. That means the amplitude is 28. Okay, because from the middle you go up 28 and you go down 28. So there's your amplitude. We've got 2 pi is a normal a period, but this one has a period of 150 seconds. So we need to divide 2 pi by 150. And so normally we start in the middle. We're gonna have a shift. So I like to think of it, so this would be normally where sine starts. It starts in the middle heading upward. So I need to be able to plug in this number, so 37.5, and this sine, the sine, I should get 0 at that point because we're used to getting 0 at that spot. So I'm going to do x minus 37.5. So it's a shift to the right by 37.5 seconds. All right, and the middle height is 28.5, so plus 28.5. So there's our equation. Okay, so I guess we just find out when that equation has a height of 50. So I'm going to see if I can move this over. I'm going to say 50 equals 28 sine of 2 pi by 150 x minus 37.5 plus 28.5. All right, let's subtract 28.5 from both sides. You get 21.5. And divide both sides by 28, right, because of this. So so we're going to subtract the 28.5, and then we're going to divide by 28, and that is equal to sine of 2 pi over 150 x minus 37.5. All right, now Be careful. It is not time, right now, it is not time to start dividing by 2 pi or multiplying by 150 or doing anything. Right now we're talking is the sine of all of this. The only way to get that out is to take the sine inverse of both sides. But as soon as you hit sine inverse, remember that your calculator tells lies. You have to do it properly. So you're going to need your unit circle next to you for this. So I will take the sine inverse of both sides. I'm going to say the sine inverse of 21.5 over 28 is equal to 2 pi by 150 times x minus 30. Here, I don't like it when people do that, so why should I? X minus 37.5. I like to keep the top with the top. All right, now I'm going to do sine inverse in my calculator, but I'm not going to trust it. We're going to talk about what the real answers are going to be using our unit circle here. Right, so this is our unit circle. Now I do know it's going to be, it's a positive number. 21.5 over 20 is a positive number. So my calculator is going to give me this angle right here. But it's going to forget that there's another angle that will also have a height of 21.5 over 28 right here. So even though my calculator is only going to give me this angle, I have to calculate this angle too. But not only that, there's another angle, which is 2 pi plus this first angle. And there's another angle, which is 2 pi plus this second angle. So I'm going to go around once, plus up to the second angle. And of course, we're doing 3 full rotations here, so there's another one. So basically, I'm going to find this angle using my calculator. I'm going to do this angle knowing my symmetry in the unit circle. And then I'm going to add 2 pi to both of these guys twice. All right, so let's see what we get. 21.5 divided by 28, and take the sine inverse of that. All right, my calculator is telling me that this angle is 0.875 approximately. Let's see if that makes sense. Pi by 2 is half of pi. It's about 1.5 something. So 0.875, yeah, it's more than halfway up. It's about here. So the other one that we just kind of have to know because our calculator deceives us is we can say pi minus that same amount, and that should get us to this side. Right? Pi gets us all the way across to this side, and then you just go minus 0.875. So I'm going to say pi minus that is 2. So we have 0.875, and we also have 2.266. Okay, I'm also going to add 2 pi to each of these because I know there are more answers. And I can subtract 2 pi, and I'm just going to keep going over and over and over until I have all the answers that can suit my needs. Maybe you don't know where all the answers are yet, but if you just kind of, once you have the final answer, you can kind of look to see which ones, look to see which ones are actually in your range that suit your question. Okay, so there you go. And I could go plus 6 pi, plus 8 pi, plus 10 pi. I could do minus 2 pi, all of it. Okay. Now, each one of these individually are going to equal 2 pi over 150 x minus 37.5. Okay, equals 2 pi over 150 x minus 37.5. Right. 7.5. There we go, all the way down. And okay, so now it would have been a mistake if I did all of the calculations for this first one and then started adding 2 pi. You have to find the other arm and start adding and subtracting 2 pi before you start finishing off the equation. Right? Otherwise, you're not going to get the right answers, okay? So let's do this one, this first 8.875, and we're going to have to do 75. We're going to have to multiply by 150. Right? We're going to have to multiply by 150. We're going to have to divide by 2 pi. and then we're going to have to add 37.5. Multiply by 250, divide by 2 pi, and then we're going to add 37.5, and that's going to equal x. But that's just one of the answers, right? This is the one your calculator would have given you if you weren't clever enough to know that there are going to be more. So let's just check that out. By the way, I'm going to do it, once I have that answer, I'm going to kind of ignore all of these and show you a different way to get them all so that you don't have to recalculate each and every time. All right, so here we got 58.4 equals approximately x. All right, so maybe I shouldn't have used x. Maybe I should have used t, or time, but I think you guys get the point here. All right, so now that we know 58.4, let's go back to our graph. Which one is at 58.4? Well, this is between 37 and 75. That's right here. So this is 58.4. Well, if that's 58.4, look at, we know that it's going to be symmetrical. So 58.4 is shy of 75 by 75 minus 58.4 by 16.6. So this dot should be 16.6 seconds more than 75. So add 75. So this is going to be at 91.6. Okay, and if we go up here, we know this is 225. Well, what is, I just have to do 58.4, and I could actually just add 150 seconds. Right, so 58.4 plus 150, that's 208.4. Now I could say, I could add on another, whatever this distance is and that distance, or I could just take my 91.6 seconds and add on 150 seconds. That's a full cycle. So go 91.6 plus 150 seconds, 241.6. I'm going to go ahead and just add 150 seconds to that, 391.6. And right here, I'm going to go 208.5, 208.5, or 0.4, 208.4 plus 150 seconds is 358.4. All right, so it's asking you to determine the time intervals where the rider can see Niagara Falls. It looks like the rider can see Niagara Falls. Therefore, the rider can see Niagara Falls between after 58.4 seconds until 91.6 seconds. Then again, between, does he have to be over 50, or is 50 good enough? They are higher than 50, so this should be an open bracket. All right, so 208 to 241.6 and 358.4 to 391.6. There you have it. Those are the 3 times where the intervals of time where the rider can see Niagara Falls.